Hey guys, Mr. Backerberg here. In this video, we're going to look at applications of right triangle trigonometry. So as we're taking a look at a triangle always has 6 parts. It's got 3 angles and it's got 3 sides. But we don't need to know all 6 of the parts to determine triangle congruence. And back in geometry, we actually learned several different ways of showing that triangles are congruent to each other by using only 3 parts. And using trigonometry actually allows us to take this one step further, because now we've got all the tools that we need in order to find all of the missing parts of a triangle. So as we're solving a right triangle, that's what that means. Solving a right triangle means that we're finding all of the missing pieces based on the information that we have available to us. So we're going to take a look at a triangle, and I'm going to give you a little bit of information, and we're going to use that to help us find the rest of our information. So we're going to deal with a right triangle, since we've got a right angle in there. This angle down on the bottom left-hand corner, I'm going to call a 37-degree angle, and this hypotenuse length, I'm going to call 8. And what we want to do is find all of the missing pieces of our triangle. So this vertical side over here, I'm going to call A, and this horizontal side over here, I'm going to call B. Now, because I've got 2 of my angles available to me, I'm going to go ahead and find this missing third angle right away. We should remember that all of the angles inside of a triangle add up to 180 degrees. So if I subtract off this 90-degree angle, and if I subtract off this 37-degree angle, then that should leave me with 53 degrees up here for this missing angle. But now we've got these missing sides. We've got this A side and we've got this B side. So we're going to use some trig to help us out. And I'm going to focus on that 37-degree angle. And let's go ahead and find side A first. So if we're looking at the 37-degree angle, A is opposite, meaning that it's all the way across the triangle. And we were given the 8, which is the hypotenuse. So if we think about opposite and hypotenuse, that's a sine function. So if I take the sine of this 37-degree angle, then that's going to equal that A side over the 8. So now if I want to solve to get A alone, well, right now we're dividing by 8. So in order to get rid of division by 8, I have to multiply both sides by that 8. So I end up with A equals 8 times the sine of 37. Now before you type this into your calculator, we're dealing with a degree angle, so we should double check to make sure that our calculator is in degree mode. When we type this in, if we do a little rounding, we should get our A value to be approximately 4.81. But we also need to find this B value, and B is adjacent to that 37-degree angle, and I'm going to use that hypotenuse of 8 again. So adjacent and hypotenuse means that I should set up a cosine equation. So the cosine of that 37-degree angle equals the adjacent side B over the hypotenuse 8. Now again, we're taking B and we're dividing it by 8, so I'm going to multiply that 8 over to the left-hand side. So I get B equals 8 times the cosine of 37. And again, we should double check to make sure our calculator is in degree mode before we start typing anything in. But when we do this, we should get a B value of approximately 6.39. Now, a lot of times as we're using trig in application problems, it involves doing some sort of indirect measurement. So we're going to say that we're taking a look at the height of a building. And what we're going to do is we stand at a distance of about 340 feet away from the base of the building, and we measure the angle of elevation up to the top to be about 65 degrees. And what we want to find out is how tall the building is. So as we're looking at what we've got from this 65-degree angle, the h value, the height, is the opposite side since it's directly across from my 65-degree angle, and the 340 is adjacent to my 65-degree angle. So because we're dealing with opposite and adjacent, then we're going to write out a tangent equation. So I would say the tangent of this 65-degree angle equals the opposite side h over the adjacent side 340. Now to get h alone, I would multiply that 340 over to the other side. So we end up getting h equals 340 times the tangent of 65. And before I type this into my calculator, we're dealing with a degree angle, so I should double check to make sure that my calculator is in degree mode. So we get a height of approximately 729 feet when we type this one in. That's going to be it for this video. Thanks for watching.